Welcome everybody to day 3 of our course. I just dropped the link in the chat for our attendance. Please take 30 seconds to fill it out. I'm gonna go ahead and drop it again in case we have people coming in. If people ask about it when we start, please reference them to the Zoom channel if you can. I'm sorry, not the Zoom channel, the Slack channel. But today we're gonna pick off from where we left off yesterday. I believe we finished lesson 2 of the course. So we should be able to move on with lesson 3, right on schedule. Let me go ahead and share my screen. I'm finally home, so I got like all my screens now, which is so convenient. We should be looking at the Python ordered data structures. We're going to introduce something that we've kind of seen already earlier in the last couple of days, and finally talking a little bit more about what it actually is and how to work it. Can you please go over the assignment today? It is driving me crazy. I keep getting the outcome of end at 2. What assignment specifically, Norma? Are you referring to the ones at the very bottom? I'm assuming you're referring to these. Um, Norma has gone quiet in the chat. But yeah, I guess before we start and dive deep into Python 3, we can kind of try these out real quick and see how they work. We did a little bit of them yesterday. So maybe we can do the first two before we actually start off with the curriculum. But yeah, we can definitely take the time, kind of try it out. So let's look at it. We start off a little bit yesterday. We're gonna go ahead and kind of finish off the first one, and then we'll do the second one. But essentially, we had what we call like our variable bank that we can kind of pull from, and using these different variables of all different types of data types, we want to complete the lines of code here to reach a specific outcome. And that outcome was to trigger the congrats message nested within these conditional statements. So yesterday I did start you off. We had if var1, which is a boolean for true, and that was enough to kind of get us started and going in here, which is good. All right. The outcome that we wanted was printing congrats. So we wanted to come in here, and then we dove a line deeper or a level deeper into our code. Now, how do I know what level am I? It can get very confusing, right? The more lines of code that you're working with it can get very intimidating. And Python is very nice. It provides you with these lines right here, right, to show you like what level of your code you're kind of on, right? At the very top level, right? We have right here, which is start the if var1, and you can see here is where is the end of this conditional statement. Because typically when we think about if statements, we think about if else, right? So what happens if this var1 doesn't pass? Where is the else specifically for this condition? Well, this line here represents the other half of it. And if you go all the way down, if for whatever reason we failed this if check, it's going to default to this else check at the very bottom. Right. So this right here is the top level. We do not want the else to trigger. We actually want to come in here to ensure we can dive deeper and reach our congrats message. So we did that successfully. It brought us into the next level in here. So which I would say like level 2, I would say, right? And this is another if else, right? Here's the if. We have an elif right here. And then here's the else at this level, right? So this is like level 2. This is if, elif, and the else statement. And I know that because of the line where these are kind of etched to the side of. this shows me what is the top level for this specific level that we are currently working on. So I don't want to come in here, right? This if statement here, I don't want it to pass because if I do, I don't have anywhere else to go that would take me to congrats. So I want to ensure that I fail this if statement. I don't want it to default to the else statement, and I want to come in here. I want to come in this else statement so I can eventually get to congrats. So I need to add some kind of variable that's going to fail this if check, right? So whatever variable in here that's going to allow me to do that, I need to find it out, right? So what comparison between the integer of 33 is going to give me a false comparison and not continue onwards? Well, if whatever number I put to the left of this greater than symbol, if it's greater and it succeeds, it's going to go in here. So I need to make sure that it is less than, right? And the only one here, as Norma suggests, it's going to be var 6, right? So I'm going to say if var 6, and that's going to guarantee me that this fails and it does not go in here, right? Which is good. So I know that this is going to fail. It's going to bring me to the else statement. And that's good. We want to get this to trigger, right? And we do not want to go to the default. So I need to make sure that this else statement works. So I need to make sure that the comparisons for the 20 and the 30 is correct. So what can I put here is going to be greater than 20. Well, either var 4 or var 5 will work. It doesn't really matter which or the other you use. We'll say var 4 for the first one, and the second one we can say var 5, just for the sake of not repeating ourselves, right? But this should pass, right? Both var 4 and var 5 are greater than what they're being compared to, therefore succeeding on this else check, which brings us in here, right? We are now one deeper. So we have an if statement and an else statement. I need this to pass, then I'm getting closer to the congrats. If whatever plus 20 is equal 85, then I want to do the following. So I need to get a number that equals what this 85 is. I see a var 5 here, so 65 plus 20 will give me 85, so that's a perfect one here. So let's say var 5, all right, which will move us along. And then we have if not. What can I put if not that's going to give me something successful to trigger this if instead of the else? All right. Well, I believe we could probably just do something as simple as if not var 2. And it gets us in that 2. If not what can we do? If not var 7. Oh, this is in a while. And the 2. Yeah, so it's failing. Why am I getting in that 2? We have
Your var 5 is not less than 30. Var 5 is 65.
Can you say that again?
So var 4 is greater than 20, and you have var 5 is less than 30, but that's not
Oh,
true, so that fails. So it has to be var
thank you.
6.
My apologies. I got that one wrong. Yeah, so This failed, right? The numbers that we have here aren't going to work specifically. So we have to get creative. I know a method that we can use. And I didn't teach it to you guys specifically, but it's a built-in method, right? Um, who can take a quick wild guess at what it may be? What item in here? Oh, my bad. Oh, we do have bar 6. My apologies. Yeah, we do have bar 6. Bar 6 is less than 30, so this one works. I think there's some other ones around here that does not have a number that's less than. If not var 1, and that's 6. Okay, now we're coming in here. So var 6 does work. Sorry, I was getting confused with a different one that we have here. There's one area, one of these exercises where we don't have a number that is going to meet the expectation of the comparison, so we have to get very creative. But thank you for pointing this out. I did get tunnel vision. If not var 1, if not var 2, if not false. There we go. I hardcoded it earlier. The false in here. This gives me if not var 2. Where is the? Okay, we have the 6 here. We have the set. Okay, if. Yep, which would pass. Then it comes in here. It's netted, and now it's comparing if green is equal to hello. And then the else, which is n at 7, is giving us n at 7. Okay. So this is a little out of scope, right? What is if greeting is equal to hello? Obviously this isn't working, right? It's failing and it's giving you the 7. This isn't correct, right? This if check is failing, therefore it's resorting to the else check right here and returning n at 7. This is something that I did not teach you yet. It is a little out of scope. If you did some research, you probably would have solved it. But this is accessing this greeting and hello here. We have not talked about this data type. This is an unordered data type, which is known as a dictionary, right? And they get their access fairly similar to how lists are accessed, which is what we'll talk about today, right? And that is by using bracket notation, where in a list you access items using the index, right? In a dictionary, you access the items using what we call keys, right? Because the way that dictionaries are structured is by key value pairs. We won't dive too much into it, which is why I said, like, it is a little out of scope because we have not taught this to you guys yet. So I don't know why it is showing here this early, but essentially, if I wanted to access what hello is, I would have to call the key that it has assigned, right? This is a key value pair where we have greeting and hello. The key is a greeting, and the value that is assigned is hello. Here's another key value pair where the key is age, and the value assigned to it is 33. So the way that you access values is you have to call the key of it, right? So you have to say bar 7 key of greeting to get hello, right? Very similar to how when you access item in a list, you use index notation. And this might kind of go over your head if you're new to this, and that's okay, right? It'll make more sense as we start introducing these different data types. But to fix this and complete it, I'm gonna go ahead and do it. So I'm gonna say bar 7 key of greeting, and it's gonna ensure that it's gonna check it against hello, which is correct. And this should work now, and that it did work. I'm now getting an error at this line, so that means that this did pass, right? It did compare it the greeting with hello, which is correct, right? Because this is going to return whatever value is assigned, which is hello, and then check if the value is equal to the string of hello. So this was successful. And then finally, we get to the very last if else statement here, which is if the length is equal to 4. Well, what is this? What is length? This is a built-in method, and there's a very similar method of doing this in JavaScript as well. But length allows you to get the length of something, right, within those parentheses. Python length. Right here, we're able to get the length of a list. We can get the length of a string as well. Right, notice that they saved the string of hello into this variable called list, and then they ran the length method around the list, and we can see what that returns for us. This is 1, 2, 3, 4, 5 characters in here, so it did return 5. Right, so the length method returns to you the length of whether it of a string, of a list, or some kind of sequence, right? And that's what the length does. So I know we didn't talk about it, but a quick Google research would have led you to this outcome, right? So this is checking if the length of something is equal to 4, then I want to print out congrats. So that means we have to run the length method on something that's going to return to me hello. Well, what can we use? Well, we can't use it on the Booleans. It won't work on var3 because, as we just saw here, the hello is going to return to me 5, right? There's 5 characters long. We have 3 integers, so that's not going to be successful. But what we do have is a list here. This list here, var8, has 4 items in it. 1, 2, 3, 4. There's 4 things in here. If I were to run the length method on this list of different items, I know it's going to return to me 4. Right? So I can do if length of var8, and then run the length method. This will return 4, and then we're going to compare it to the integer 4. This will succeed, therefore giving me my congrats method at the end of it, right? Do I have any questions in regards to how we reach this outcome?
Yeah, as far as like I guess being the accepted method of doing it, the last bit there, I used var8 and accessed item 1 because this is 4 letters long.
Yeah.
Is there a preferred way of doing that?
No. There's not.
So it just happened to be that that list is 4 words long and this is 4 letters long.
Yeah, well, finding something that can give you this check to pass. A lot of things in coding, my friend, there's no right or wrong answer. As you progress through coding, you're going to learn more efficient ways of doing things, right? Like ways to optimize your code so it runs more efficiently. It uses less memory. Maybe it's cleaner to read. You know, you might ask yourself later on, what is good code? Is it something that's easy and readable, right? Well organized? Is it code that runs very fast? Is it code that doesn't use a lot of storage? What defines good code? I believe it's a huge combination of all 3 of them. But there is no right or wrong answer, right? The way that you reach an outcome might be different than how everybody else in this room reach the same outcome, and that's okay, right? So there's no right or wrong answer to do things. There are better ways of doing things, and there are worse ways of doing things, but there's no right or wrong way of doing these things. Does that make sense?
Yep, thank you.
All right, right on. But yeah, getting the item at index 1, which is this, and then giving the length of the string works the same way too. So either one of these would have reached that outcome, which is good. hopefully that answered your question, Norma. Maybe this kind of gave you like a little bit more insight of how to reach this outcome. But yeah, we're not gonna go through the rest of these. These are for you guys. If you guys have a specific question on any of these, we can talk about it either on a break or individually after class. Let's go ahead and move forward with today's lesson, which is going to be the ordered data structures. We're going to open it up. So we talked about a couple data types, right? We talked about the most basic ones. We talked about strings, integers, floats, booleans, and now we're going to start talking a little bit more about the more complex data structures out here. Well, data types and data structures are two different things, right? Data structures are essentially like, groups of different data types, right? And we have ordered and unordered data structures. The first one we're going to talk about is going to be the ordered data structures, right? And this is going to be your list and your tuples, right? And as you've already seen, we've had a brief introduction to them in passing as we've gone through these last couple of days. It's very hard to cover a subject without seeing other new subjects, which is why I tell you kind of just be patient a little bit. And I try to explain it as best as I can without confusing you too much and without going on different tangents, right? But the very first one we're going to talk about is going to be our lists, right? And lists, very similar to strings as well, are sequences, right? They are a sequence of characters. We talked about strings and how you can access different characters in a string by an index, and lists are the exact same thing, right? Strings are a order of different characters. It's the same thing with lists, right? So this little diagram that you saw on day one also is relevant to lists, right? The way that you read a list is by the index, right? Starting at 0 and onwards. And then you can also do backward direction indexing, but it'll start at -1. Lists are identified by the brackets that define it, right? And you saw that on here, right, on the assignment. I knew by looking at bar 8 that this was a list because of the square brackets to the left and to the right of it, right? This is what defines a list. And there's two ways of creating a list. One, which is the way that I rarely see be used. To be completely fair, I didn't know that you can create a list this way until I was writing this curriculum, and I was like, "What the heck?" I didn't know you could do this. But you can create a list by just calling a list method. You specify the term list and open and close parentheses, and what this will do is create an empty list for you. Right? This is one way of doing it, and one way that I rarely have ever seen before. And you see here, when I created this list here, I ran it, and let me write this in print to ensure we have good habits here. But it prints out an empty list, right? There's nothing within this list. All it does is print out these empty square brackets because there's nothing in here. The more common way of defining a list is literally by doing something like my list is equal to open and close square brackets. This is how you typically see an empty list be created. You just open up some brackets and just leave it empty. Simple as that, right? And we're going to talk about how we would add new items to the list or remove them as we progress, right? But to create an empty list, you can either use the list method or just open and close some square brackets and call it a day. One thing that you might notice, especially if you've done some other coding with other languages, is that some languages are very strict with what data types you can use in a list, right? They also go by different names. You might have actually heard the term arrays, right? They're very similar, but they do have their differences We won't get too deep into the weeds about how they're different. Just know that in other languages, lists or arrays tend to be logged to a specific data type. In Python, we don't care. We can mix up data types. We can have strings. We can have integers. We can have floats. We can have other lists inside of lists, which you will see later on. But we don't discriminate, right? We're rated E for everybody. This list can be whatever we want it to be. All right. List is a Python built-in method name, right? So it's a reserved keyword. So you don't want to like name a list just list, which is why you see me use like my list. And I believe I've never really done this, but it can be overridden. So just be aware of that. So here we have a small example of how you create a list with content already in it, right? So just as how we created an empty list, you're able to create a pre-filled out list, right? Here we have, I'm not gonna run this, but notice here how this was an example to show you that you can create a list called list, but you don't want to do that. Let me clear my outputs. But here is a list that was created with a pre-formatted list going from 0 to 9, and they're printing out the list. So you can either create an empty list or pre-fill a list with the contents that you want in here. This list is just a bunch of different integers, right? But as I mentioned before, the data type that you put in here, it can be whatever you want. Here is a list of nothing but strings. Now, the items in the list are, once again, separated by commas. So that's how you identify where the next item in your list, starts. So it's pretty straightforward. Lists are, what the name implies. It's a list of different things, right? It can be strings, integers, floats, whatever your heart desires. But it just allows you to hold multiple different data types or data values in general. As I mentioned to you earlier, lists can contain other collections, such as lists or other data types, but it can hold a list in itself, right? Here we have a list with lists. The first 3 items within this list are just strings, but the 4th item in list with lists, it's another list, right? So although we can have different data types in here, we can also have other data structures within a list. This is considered a nested list because it's nested within another list, right? Okay. So moving on. List operations and methods. The first thing is printing out a list. So here, our small demo, we have a travel bucket list of New Zealand, Antarctica, Italy, Chile, Fiji, Ireland, and Morocco, right? By running the print method on the entirety of the list, it's going to do as such. It's going to print for you the entirety of this list. Now, that's cool and all, but what if we only wanted to access one item at a time? Well, just like we did with strings, we're able to access an individual character or an individual data value within a list by using what's known as index notation, right? Or another word that you might have heard or hear will be bracket notation, right? Which is using the open and close square brackets with the index of the value you're trying to access, right? So the way that you would do that is you would call the name of your variable, right? Which in this instance, it is a list, right? We call that list travel bucket list. And then we end it with open and close square brackets specifying the index of the item we're trying to access, right? Here's a small description of what the syntax of that looks like, right? List variable, and then they open in square brackets with n being whatever number you want to be representing the index of the location of the item you're trying to grab, right? When we run this, you see here that it returns to me Fiji. Let's practice in print statement, how it should be. But it does print out Fiji for us, right? It accesses Fiji and then we print it out, right? Which is accurate, right? Fiji is index 4. Remember, index notation starts at 0. So 0, 1, 2, 3, and 4, right? So Fiji being accurate. All right. Just like in strings, we were able to slice a string and grab different parts of that string with a start and an endpoint. You can do the same for lists. Right here, I'm gonna go ahead. I'm gonna print out travel bucket list. I'm gonna open up some brackets, and I want to grab everything from index 2 and onward. And when I run this, it's going to truncate New Zealand and Antarctica, right? And it's going to start at Italy, which is at index 2. It's going to grab everything to the right of that, right? So just like we were able to slice through a string and grab a start and an endpoint, we can do the same thing here. Because I did not specify where I wanted to end within the bracket notation, it grabbed everything all the way to the end, right? But let's say we specify to index 4, and notice that now I only get Italy and Chile. So we are able to grab certain sections of the list using the start and the stop on the brackets, right? You are able to use the step method as well. Notice we're doing something very similar to how we did it with the strings here. We do not specify the start or the end, but we're going to go backwards, right? And it reverses the string, right? I showed you guys this, I believe, on Monday. So this is one way of doing it too. So you can use the step method, right? Let's do it in order, but let's step over every other one, right? We start at New Zealand, step over Antarctica, we print out Italy, which is good. We step over Chile, we print out Fiji, and step over Ireland, and we print out Morocco, right? So you can do the start, the stop, and the step method, very similar to how we did it with strings as well. It's still the same. Now, we know how to define a list. We know how to define a list with content in it. We know how to access items in there, whether a very specific index or we know how to access items within a range of different things, right? A range of numbers, slicing. Now, how do we change a value within my list? Well, let's look at it. Here's our first example. We have travel bucket list, and we're trying to grab the content where that's at index 4, right? Index 4, what is that? 0, 1, 2, 3, 4. That's Fiji, right? What they're doing here is they grab the item at index 4 and notice that it's followed by an equal sign and then the keyword Texas. Right. So the same way how we assign values to a variable using the equal sign, right, to give it some kind of value, they're doing the exact same thing here. You call the list that you're trying to access, specify the index of where you're trying to add a value to or change the value to specifically, and then just give it the value. And let's see what happens. Let's run this. We change the value to Texas, and then we print this out. And we see here that Fiji is no longer here, and we now have Texas, right? So this is index 4. This is index 5. This is 6. What happens if I try to do something like index 8? Well, I'm gonna get an error, right? List assignment index out of range. So it won't work if you specify an index that it doesn't go up to, right? So just be aware of that. But because index 4 does exist, we have enough items within our list, it'll work with no issue. I just want to make sure that we understood that. But yeah, if you want to change the value of an item within a list, you want to just call the item and just reassign it um, a new value. I understand we've been going pretty quick. Do I have any questions before I move forward? Awesome. List operations. So we saw this one already in action at the beginning of our class. But length. Length. Oh, my apologies. I just saw the chat. Okay. What would you use a nested list for? You're gonna encounter a lot of nested data structures in your career, Joseph, right? And it's not just gonna be nested lists, it's gonna be nested lists with dictionaries within other lists. I want you to think about, what if I had a record, right? Like let's say I was in charge of the school record for some school, right? And I have like a list of students. Each student have in like in the system, each student has multiple different lists, right, of their classes. What if I have one value which is like classes? Well, each class also has individual data, right? So I might have a list of all classes, right? And there's a list of lists in there where each class also has a list of the class name, the teacher who teaches it, the room number, right? The class subject, right? So I might have a list of lists in there where I have a list of students, and this list of students are lists themselves of different information that they have, or they might have a list of all their classes, and each class is a list of itself with the different information that goes into this data. Now, this is very complex, right? I might want to use a different data structure. It's not a good idea to just have a bunch of lists. And you'll learn this later on, why you would use lists over dictionaries or dictionaries over lists in what situation. But it will depend on your scenario, right? Where you're working at the company, what type of data you're working with. But you are going to encounter nested data structures throughout the rest of your career. So you'll get good at it, I promise you. Daniel Aubin asks, is that a permanent change to the list? Yes, it is, Daniel. It is a permanent change to the list. That's a very good question, right? Lists, are they immutable or mutable? Lists are mutable. You can change them. Unlike strings, right, that whenever you try to change a part of the string, or if you try to change a string, it'll recreate a new string. Lists are not like that. You are able to freely update the contents of your lists, and it will change. It won't recreate a new list. That specific list will change, right? How the information is handled in memory is a little too complex for this class, but every single item within that list is stored somewhere different in your computer. They're not all within the same location, right? Unfortunately, right? Which is one of the reasons why list isn't like the best way of storing large amounts of data, because finding that information in your computer can take time. But it does have different locations for the different data values that you might have in there, and you are able to change them. So just be aware of that. Lists are mutable. They are not immutable. You can change them, freely, and it is permanent if you change them. Joe says, so it makes it possible to separate by different subcategories. Of course, yes, it is. It does make it possible. I got asked about the attendance page. For those of you who might have joined a little bit late, that's okay. Here is the link to the attendance page. I see Joseph already took care of it. Thank you, Joseph. All right, let's go ahead and move forward. So we saw the link method in action. The link method will return to you how long some kind of data structure or data type may be, whether it's a string or the length of the list. So we won't dive too much into it. So I'm just gonna go ahead and run it. It returned to me the value of 7 because there's 1, 2, 3, 4, 5, 6, 7 items within here. Right? Not to get confused with index notation. When you run the link method, it's gonna start at 1. Right? So if you're trying to find out how many items are in the list, it will start the count at 1. The index notation is the only thing that starts at 0. So just be aware of that. Don't get those confused. It happens. We are able to use membership checks, right? We can use membership checks. Just like we saw yesterday, we can check if a piece of a word is within a string. You can do that with lists as well, right? I'm gonna go ahead and run this cell block here, and notice that we're printing out the result that's going to come back from doing a membership check of Fiji inside of travel bucket list. And as we already saw earlier, we replaced Fiji with Texas. So print Fiji in travel bucket list should return false. And then we do a second membership check where we're now checking for Texas in travel bucket list, and this one should return true. And as I expected here, it did as such. So we're able to check if something exists within a list. Now, am I not screen sharing? Someone said screen sharing in the chat. Let me stop screen sharing just in case and then reshare again. Well, just in case, Trevor, hopefully that fixes it for you. Let's go ahead and move forward. So yeah, we are able to do membership checks, see if something exists within a list. So here's some other methods. I haven't used some of these before. It's just here to also show you like what is there for you. I'll tell you which ones are very common, so you're aware of that. The length method is a very common method. I love it, or I use it a lot. So don't forget that one. Checking the length of like strings or lists is really useful. So I use this one a lot. Checking membership checks and lists are helpful. I do want to give a disclaimer on this, and this will make more sense as you progress through your career in coding if you decide to move forward with this. When using a membership check, right? It isn't magic, right? When you do something like Texas in travel bucket list, what's happening behind the screen is that your computer is grabbing this list, right? Right now, it's like 7 items, which is no big deal. And it's going to go through every single item individually. And it's going to say, hey, are you Texas? Nope, next one. Are you Texas? Nope, next one. Until it finds a match, right? Right now, it's not a big deal because there's 7 items in your list. Where it becomes an issue is you have thousands or millions of different data values in your list, and you're trying to see, hey, does Texas exist here? And now your computer is having to run through every single item in this list to see if it exists, right? It's not a big issue right now. I don't want you guys to like dwell too much on this thought, but hopefully this gets you thinking when we start talking about other data structures, and the speed of how you're able to see if something exists within it, and why you would choose one data structure over the other, right? But yeah, that's something that I wanted to kind of get you thinking about. This does check every single item individually from start to finish in your list. So just be aware of that. Texas will tell you it's there. Yeah, you're right. All right, let's go ahead and move forward. We have our list methods, right? So we talked about how to update a current value on our list. Now, if we want to add something into a list, we have a very helpful method, the append method, right? This is, once again, one of the most common ones to use. This is how you're going to be adding things to a list. Append, as the name suggests, you're appending a new item into your list, but it's going to add it at the end of it, right? It's going to add it automatically to the very end of the list, almost like if it's in the line, right? So we had our travel bucket list, and this is what it looks like right now, right? At the very end, we have Morocco, right? And we're going to use the append method, and we're going to append a new place, which is going to be Germany, right? So we run the .append method. You call the list name, you invoke the append method, and then we're going to print out whatever travel bucket list is to see what it looks like, right? And here we have the updated list. Here's Morocco, and we now have Germany to the end of the list, right? So we specifically tapped out Germany, so it added to the end. And you can add whatever you really want in here. You can add append 1. You can add, false or true, whatever you want to do here. It's going to add it to the end of the list, right? It does not matter, but whatever you want to add to it, you would do it at the very end. By default, append adds it to the end of the list. Be aware of that. Now we have another method here that's fairly similar to append, but the way that it works is with an iterable is what we call it, right? It extends your list, right? It uses the keyword extend, right? By appending elements from the iterable. So what does that mean? What is an iterable, right? An iterable is something that you can iterate through, like a list. A list is a list of different data values. So you're able to iterate through it, go one by one, and do something with the items inside of a list, right? And what happens here is when you try to use the extend method, it's going to require from you a sequence of values, right? It's going to require some kind of data structure that has a sequence of different values that it has to iterate through. And by that, I mean, it has to go one by one and slowly add them into your list, right? It has to go through the entire data structure and add each item individually. It won't work if you just add a single item, and we'll see that in real time, right? Here is what the current list looks like, right? When I run this, what's going to happen, it's going to invoke the extend method on my current list. It's going to run through this iterable. It's going to grab the first item. It's going to add it to the end. And then it's going to go to Thailand. It's going to add it to the end. And then it's going to go to Australia and add it to the end. And when I run this, it does as such. It looks a little funky here because I've ran this piece of code multiple times. So it keeps adding Germany. So let me go ahead and clear all outputs. Of course, restarts. Keep saying it. That's the only downside sometimes to Jupyter notebooks. If you run stuff over and over again, it'll keep doing it. There we go. We have Germany, and then we run the extend method. We see Germany, Argentina, Thailand, and Australia. Well, what happens if I try to use the extend method without adding an iterable like a list? If I say travel bucket list.extend, and here I do United States, and then I print travel bucket list. Look what happens. It does add United States, but not how you would think, right? It treated it like an iterable, right? Because technically it is. A string is a sequence of characters. So it iterates through every single word, I'm sorry, every single letter within my word, and then adds it to the list, right? So it treats the United States string as an iterable, right? That is a difference between extend and append, right? So if you want to add one item, you definitely just want to use append because you just want to add the entirety of that value. Extend is going to grab whatever you pass in it and treat it like an iterable, right? So it's helpful if you're using strings, I'm sorry, not strings, lists, right? So you can iterate through every single item. So you don't have to keep running the append method for every single item in this list. But if you only have to add one item, you do not want to use extend, you want to use append, right? So just be aware of that. Let's restart this again. And run these. All right. Hopefully that gives you an idea of what it should be. So we have the append. We talked about extend. Now let's talk about insert, right? We saw how whenever we use the append method, by default, it added the data value to the end of our list. But what if that's not what we want, right? What if we want to specifically add it to a different part of our list? Well, you're able to do that, right? Using the insert method, right? The insert method, it takes two arguments, right? The first argument is going to be where do you want to insert this new item? And then the second argument it's going to take is going to be the item that you want to insert in there, right? And notice here that we specified at index 0, I want you to add Canada, and then we print out travel bucket lists. In Canada, Canada is successfully added into index 0. So we know how to append at the end of a list. We know how to insert at a very specific location, and we are also able to extend our list using iterables. I don't use extend often. I probably did not use it until I started teaching this class. To be fair, I probably should use it more often. Usually, I kind of hard code this using a for loop, and we'll talk more about those later on. But extend isn't used. It isn't used too often. Insert isn't used too often either. It's helpful, but I've never really encountered a situation where I have to insert something at a very specific location in the list. It's not a very common occurrence. What if you don't give it the first value? I believe so. Joseph's correct here. It's going to give you an error, right? So some of these methods require certain parameters, and if you don't give it, it won't work. That's just how it's built. So that just keep that in mind. As a matter of fact, let's try that. Answer expected 2 arguments, got 1, right? All right, put it back. Okay, all right, moving on. We talked about the difference between append and extend. Let's go ahead and continue. We saw how append will always add the argument to the list as a single item, where extend adds it as an iterable. Would most of these methods be used to just edit the code? That's a good question. I guess the best way of explaining it how would I do this? It's sometimes very difficult to see the real world application of your code, especially when you first start off. But where I would use something like a list and appending items, um, I would say when handling data on my application, right? For example, let's say I have an application like it's a some kind of social media website, right? And you, Daniel, you decide that you want to create an account, right? Well, on my website, when you sign up, I require some information from you, right? I might require your first and last name, your age, your country, where you're at, right? Password, email, right? There's certain information that these login or sign up forms are going to request from you. Um, on top of other stuff, right? If you made accounts like Pinterest, they ask you what are your interests, like what are your hobbies, what you like to do, so they can kind of set up your algorithm for what kind of content you should be seeing, right? These forms take in a large amount of data, right, of information. So, whenever you are filling this out on your browser, on your application, this is what's known as the front end, right? What the front of the shop, what you as a user are experiencing and seeing. All right, so you might be filling out these forms and giving all this information, but how is this information being handled once it gets submitted, right? And this goes a little bit out of scope, but essentially, when you click submit or you put sign up afterwards, and all this information is being handled, it gets sent to the back end, the back of the shop, where I take all the information you give to me and then I use it however I need to use it to, do what I gotta do for you, right? Uh, and it might come in different formats of different data structures, right? And then I need to be able to grab these data structures and kind of go within the data structure, find the information, and then use it as I need it, right? Format some different uh, data structures so I can create different things for you and then give you the information you're looking for. Uh, so it can get very complex to explain this, especially if you're just starting off. But it's important to know how to access the different data structures because this is how data is sent through the internet, right? How it's handled on your computer, right? It's handled in this format. So you need to know how to manipulate it, access it, to create your websites or your applications or whatever you end up doing, right? So yes, you wouldn't necessarily edit code, but you would, I guess, manipulate data is a good way of putting it. But before we move forward, let's go ahead and take a tactical pause here and go on our first 10-minute break. Time is 6:58. I'll see you guys back at 7:08. So someone brought up during the break, one of the difficult things about coding is wondering like when should I use one or the other, right? And that's something good to bring up. Something I see very often, like, hey, like I know that I can do this or I can do that, but I don't know when I will use one or the other. Like, I know what I should, how to do it. I don't know how to approach the problem. And this kind of goes back to what I mentioned to Scott earlier, that there's no right or wrong way of doing things, right? And a good example is this extend method that we just talked about, right? The extend method, it takes a list, travel bucket list, and then you invoke the extend method, and it takes an iterable to add something new in here, right? Let's say we'll say Germany, we'll say Japan, and United States, right? We know that we have a method called extend that could iterate through an iterable and then add it to the end of this list. And it'll work just as well, right? We have Germany, Japan, United States added successfully. If you had a piece of code that it never changes, right? You will always have this list of these many items, and you'll always have to extend it by 3 additional items. Technically, it wouldn't be wrong to say travel bucket list dot append. Let's say we have this list here. Additional list items is equal to. It wouldn't be wrong to say this. And hard code every single item within here to add it. This is technically not wrong. This did the exact same thing as extending the list using the method, right? This is a prime example of what I mean. There's no right or wrong answer, Scott or Daniel. However you decide to approach the problem and reach the outcome, it's going to be up to you. What matters is, do you understand what you did and why you did it? And when you guys go through your second part of your application and you go through the interview with Guillermo, which is going to be your first skate with Platoon, we don't expect you to be great coders. You're not. Realistically, 99% of you guys are not, right? It's rarely we get a prodigy who's been doing this since he was like 5 because his parents put him in STEM, and he's just like amazing at this, right? He's been making games in his garage since he was like 8. That's a very rare, very rare. Usually, most of you guys that come here just started. They recently started picking this up, and that's okay. We know that. We know who our students are, right? Who the population that's coming to. We know who you guys are. We understand that. I need to make sure Guillermo needs to know, can you reach some solution? It might not be the sexiest solution, and that's okay, right? If you hard code it, sure, it's a little funny to us, right? Because that's there's better ways of doing this. This is not very efficient to have to hard code it, but hey, you got it done, and that says a lot, right? So this is not wrong. There are more efficient ways of doing this. Why would you hard code this when you can use a method that would iterate, right? Because this is set to only adding 3 items. But what if, for whatever reason, this one day there's 4 or 5 items on the list that you have to add, right? So like I said, there's more efficient ways of doing things to take into account other possibilities that you might encounter. But it's not necessarily wrong. This will work. This will reach the same outcome as the extend method, right? But what route you decide to take, it's going to be up to you guys, and that's okay. The important part is make a decision, right? Make a decision of how you're going to reach that outcome, right? What we don't want to see is you sitting here on your screen. You're like, you're losing your train of thought. You don't know where to go. You're hesitant, and you have like no confidence in yourself. Whatever route you decide to take, even if it's a horrible route, if it gets you to point B, that's okay. At least I'm seeing that you're thinking, you're problem solving, and if you're doing different methods, if you start doing this, I know you know how to access lists, right? I know that you know how to access list methods, how to add things there, like you manipulate data structures. This tells me a lot more than not putting any code on your screen. So when it comes to how you approach a problem, there's no right or wrong answer. There's obviously some more efficient ways of doing things, and that's okay. But your answer is not any more right than anybody else's. Hopefully that helps Daniel or anybody else that might have these like kind of questions or concerns when it comes to your code. Let's go ahead and move forward. So we talked about accessing items in our lists. We talked about a couple methods. We talked about the appending extending, and inserting, right? Now, what if you want to clear everything within a list, right? You're done with it. You don't want anything that's in it. You want to remove it and add, just clear it out. Well, there's a couple ways of doing it, right? You have a clear method where you can remove every single item within your list, and it does exactly as the name suggests. It just clears the data from your list, right? But we also have a much more specific method if you want to remove certain things. And that's using the remove method, right? Remove method and pop is going to be how you delete single items from within your list. Let me go ahead and take a tactical pause. I think I skipped something. No, this is just describing the differences. Okay. All right, so here we have the two methods, right? Remove and pop. The way these work are very specific, right? We'll cover pop first and then talk about remove. Pop is going to remove the item at the index of whatever you specify, which is going to be I, right? And it's going to return to you that item. Now, if you do not specify what item you want to remove at what index, this will automatically, by default, remove the last item within your list, right? So here in this example, we have list.pop, and then I is, an imaginary number, whatever index value you want to put in here, it's going to remove that, right? If you don't add the I, it's going to remove the very last item within your list. Remove is a little bit different, right? Remove, you can specify what item you're trying to remove. It's going to remove the first appearance of that item. This one does require you to add something within here, right? Where pop, if you don't add an index, it'll automatically remove the last item in your list. Where is Japan? Okay. So I ran this line of code here. This doesn't really matter too much. This will explain to you the difference between append and extend. But we already talked about that. When I ran this piece of code, it used the extend method to add Japan into my travel bucket list, right? And as we already know, extend treats the value that you're adding in there as an iterable, right? So it took the string Japan and it added every single character into my list individually, right? So we get something very funky like this, where we have Japan, right? Now, we're going to use the Japan method to remove and fix the issue that we now have, which is this really funky Japan. And notice that it's going to run the remove method multiple times. It's going to remove the J. The A appears twice. It's going to remove only the first entry, right? So there will be an additional A, and then the P and the N. So when we run this, let's see what it looks like. It successfully removed the string, all right, the data value that was within my list, right? But also notice that there is that additional A, as we mentioned. It's going to remove the first occurrence of the item that you're trying to remove with that method, right? And only that first one. Here, the next cell block is removing that additional A, and is no longer present within here. So here's pop. Let's remove this -1, because I believe by default it should remove the last item, which will be this additional list of Peru and Dominican Republic. It's going to run the pop method, and if you recall from the explanation, it's going to return it to you. So whatever it removes using the pop method, it's going to return it to you, which is pretty cool, because you're able to save it into another variable, right? So you're able to remove something from the list and then assign it to a variable, and that'll hold the recently removed variable. Now you don't have to do this. You could do something that's like this, where you just have travel bucket list dot pop, and it'll work the same. So you don't have to save it into a variable, but it allows you the ability to remove something from a list and then also get it back and save it somewhere else, which is very helpful, right? Let's run this and see what happens. As you see here, travel bucket list dot pop, it grabbed, I didn't specify what item, right? I left it empty, and by default, it did grab the last item in this list. It saved it into this variable called spouse bucket item, and then I printed it out, and here is that item. Well, let's look at what travel bucket list looks like. Well, when I run travel bucket list, it no longer has that nested list of Peru and Dominican Republic, right? Pop successfully deleted the last item within my list and even saved it into a different variable. So you don't have to specify -1 to grab the last item. You can just use .pop and it will remove the last item by default. Now, let's remove New Zealand. Actually, let's remove Antarctica because no one goes there. Antarctica is at index 2. So if I run index 2 in here, it specifically grabs Antarctica and saves it into spouse bucket item. And when I run travel bucket list again, Antarctica is no longer present, right? So you are able to specify which one you want to remove, and you can also receive it back and save it into a variable. So the differences between remove and pop, right? Remove is only going to remove the first occurrence of what it finds. It won't remove everything. Pop requires an index, where remove, you can specify the item you want to remove, right? You don't give it an index, right? We deliberately typed out the text of JAPN, right? We deliberately typed out the value of whatever item we're trying to remove. Whereas in pop, it doesn't take the item, it takes the index, right? So two different things that it takes. Pop, if you don't add anything to it, it'll give you the last item within the list. Remove, it needs something. It won't default to anything else, right? So you have to specify what exactly you're trying to remove when using the remove method, right? And then the final difference between remove and pop is that when you remove something using the remove method, you don't have access to that item you just removed from it. Whereas in pop, when you try to pop something out of a list, you're able to get it back and save it into a variable, right? So they have their situations. When you use one or the other, it's up to you. Whatever you're trying to do, obviously you see its usage, right? So now you have this in your tool belt. You know that you can remove things from a list. There's two different ways of doing it. Whichever route you take, it's going to be up to you, whatever the situation calls for. Chris asks, does the dot remove only remove singular characters, or can you remove entire strings? You can remove entire strings. The reason we did this is because earlier above, we used the extend method with the string Japan. And as we've mentioned before, extend will treat the values as iterables. So it broke up Japan into different characters and added them individually to our list. So we specified the individual characters, right? That's why we're doing it like that. But yes, it does take colon strings. The next thing we're going to talk about is methods for searching, right? Methods for searching through our list. We have two useful ones. Index is going to return to you the index where whatever item you put in within the parentheses first appears in your list, right? For example, if let's say I have my list here of my different countries, if I wanted to know what index is Chile in, I would use travel bucket list dot index, and I would specify what item I'm looking for, and I would put in Chile. And if Chile exists within my list, it should return to me 0, 1, 2, 3, right? This should return to me 3. In the event that's not in there, it's going to throw an error, right? If it's not contained in the list. Let's see that, right? Here we're using travel bucket list dot index, and we're searching for Texas. Obviously, Texas doesn't exist in here. You see here, Texas is not in the list, right? So it wasn't in there, so it did not work. Let's go ahead and add it in here. Travel bucket list dot append Texas, so we can see it work in real time. There we go. So I use the append method. So where did the Texas get added? At the end of the list, right? So currently right now, before I added, there is 1, 2, 3, 4, 5, 6, 7, 8 items. The index of the 8th item is index 7. So when I appended Texas, it added Texas at index 8. And then we also saw that in real time when using the index method on Texas, it did return to me the 8, right? It was able to successfully find where Texas was located in my list and return to me its index, right? And then the other useful method here is going to be the count. It's going to count the number of times whatever X appears in the list. The example here is Texas, and as we already know, Texas appears only once in my list. So when I run this count method, it should return to me only 1. And we run it, and it does as such, right? The sort method is going to be the next one. That's very helpful for us. The sort method is going to sort your lists, right? It's going to sort it in ascending order by default. And it also has some options in there, which we will talk about, right? But the sort method is going to give you the ability to sort the contents of your list. You can pass it in the option of setting reverse equal to true, right? And what it will do is it's going to flip the order of how it's organizing your list. A note to take into account is that the method, it mutates the original list. So if the original order is important, please do not use this method. What does that mean? It means it will change your list, right? People are asking in chat, does this permanently change your list? Yes, this is one of those things. If you order your list using the sort method, it will change the original. And there's also going to be another method that's fairly similar to sort, but they don't work the exact same. And we'll talk about the difference in a little bit. And that's going to be sorted, right? Sorted returns a copy of the sorted list that you can assign to a new variable, but leaves the original list intact, right? So as you can see here, both of these are going to sort the content of your list, but how you use them is a little bit different. Very similar to the pop and remove. One was returning something back to us and allowing us to save it, but one wasn't doing that, right? So both have their usages. How you use them is going to be up to you. But let's see it, right? Our first example here is going to be our travel bucket list, and we're using the dot sort and reverse is equal to true. This will mutate the original list. When we run this, notice that it is now sorted in alphabetical order from the back forward. Right, we have the T, the N, the M, and then it's going in reverse order. We can remove this reverse and run this again. And now it's in alphabetical order, right? I invoke the sort method on my list, right? And then I print out my list. And it is formatted, right? If I do reverse equal to true, it will change it again, right? Notice that whenever this is being printed out, I'm calling my original list and it has changed, right? So be aware that your sort method will change your original list. Now, let's look at the difference between sort and sorted. Notice that the sort method, I called it independently. I just went ahead, I called my list and I invoked the dot sort method. Look how sorted is being handled. Right here, instead of just calling my list and invoking the sorted method, I am calling the sorted method individually on its own. Whereas the sort method was being invoked on my list itself. Sorted doesn't work that way. You have to call the sorted method almost like how we ran the functions yesterday, right? It gets called individually. And notice that inside it takes the travel bucket list. Reverse equals true is optional. So let's go ahead and remove this real quick. But this is how it would look like. You call the sorted function. Inside of this method, you pass in the list you're trying to sort. And what this is going to do, it's going to create a copy, right? It creates a copy. Unlike the sort method that will mutate your original list, sorted does not mutate it. It'll create a copy and it's going to allow us to save it and recreate an additional other list. And notice here that we are recreating a new variable here, other sorted travel bucket list. And we're going to save the copy of what comes back from the sorted travel bucket list. Next, I'm going to print out both of these. I'm going to print out the original, which is a travel bucket list. And I'm going to print out the new list I created. And we're going to see here that these differ. Originally, this is how my travel bucket list looked like. It was sorted in reverse format, right? So Texas was first, and as the list went on, it was in reverse alphabetical order, right? So that checks out. When I used the sorted method on my original list, it created a copy of my list sorted, and it saved it into a new variable. So when I print this one out, this is what came out of this one. I was able to recreate a new list with the sorted version of my original without messing with the original copy, right? So the way that sorted and sort work or use are two different things, right? Dot sort needs to be invoked on the list you're trying to use it on, or sorted gets called on its own, and you pass in as an argument the list you're trying to sort. One mutates the original, where the other one doesn't affect the original, but it will create a copy that allows you to save it into a different variable. I know this might be a little confusing, so do I have any questions about everything I just said?
Yeah, the other sorted travel bucket list variable, and then you have the minus symbol, and then the sorted travel bucket list. What's with the minus symbol there?
Yeah, we're creating a whole new list, right? This is me creating a new variable called other sorted travel bucket list. And the value I'm assigning it right here with the equal sign is going to be whatever returns from the invocation of the sorted function.
No, my eyes are just getting old. It looks like a minus sign.
Oh, you're good. Anybody else? We'll zoom in a little bit. All right. Do I have any questions before we move on from lists? Anything that we have covered? We covered a lot, right? We talked about how what lists are, how we create lists, whether using the list method or using a bracket to create an empty list, or even creating a list with content already in it. The different data types that a list takes, how to slice through a list, how to access items in a list. We talked about membership checks. We talked about the different list methods. Right, there's a lot that we covered. If you want to know more about lists, I challenge you guys to come to like W3 Schools. You can go to Python lists and learn more about it. You can go to list exercises and try out the different list exercises here. Like accessing the list here, clicking it. What will be the result of the following? This will be cherry, right? So just, this will help you kind of read code and practice the different rules of how to access or do things with lists and whatnot. These are fairly quick. There's not too many questions here. Here, print the second item in the fruits list. That's going to be bananas. So we want to say fruits. Index 1. Submit answer, right? So W3 Schools is pretty cool. It gives you a couple exercises to do, especially if you feel like the exercises in our lessons aren't enough. You can always come here and try them out. And they have a good amount of different things. Like just on the subject of lists, you can talk about accessing, changing them, adding lists, removing. Loops a little out of scope because we haven't talked about looping through stuff yet. But yeah, there's different exercises here for you guys if you feel like the exercises in the curriculum are not enough. So take advantage of these. If you want to learn about the list methods here as well, you can try them out here as well. I think the only one that we didn't do from here was copy. Returns a copy of the list. But for the most part, you saw all of these. Reverse, I think we didn't do. The ones in the curriculum are pretty much the ones you will see. These are all the common ones except extend. That was new to me when I first started working with this curriculum. I had not used extend. Oh, we do have list copy. Return a shallow copy of the list. Where is it here? Yeah, we didn't have an explanation of it, but copy is one. I don't think I've ever had to use copy, if I'm being honest. But do I have any questions before I move forward to the next subject? All right. Tuples. Tuples. What are tuples? Tuples are another ordered data structure. They are very similar to lists. The difference with tuples and lists is that tuples are immutable. Right? Once again, what is mutable and immutability? It is the ability to be able to change something. Right? Tuples are not, you can't change them. Right? They are set in stone. You can't manipulate them. And what separates the tuple from the list when it comes to identifying them is how they are created. And that is by the difference of the brackets. Tuples use parentheses instead of square brackets, right? So you're able to identify these between lists. Because they are immutable, you're not able to add or remove things from them or edit the items within the tuple, right? They are set in stone. You might be able to, reassign it, but you will be recreating something new, right? You have to override the entire structure. When to use one or the other, it is honestly the best explanation is when you have data that's going to stay static, right? And what kind of data can you think of off the top of your head that won't change? What numbers or stuff outside in our real world we know that for the most part they don't change?
Area codes, zip codes.
Correct, right? So stuff like that, right? Grid coordinates as well, specifically. So there's certain data that is constant, and that probably should not change. So this is a good time of when you might want to use tuples, right? So there's two ways of creating tuples. One way is if you have multiple items in a tuple, right? You would open and close parentheses, and then you would add the items within here. If you want to create an individual item, then you have to add a comma, right? I don't know why it's like that. I'm not gonna lie to you. If you only want one item inside your tuple, then you're gonna require to add this comma here to not give you an error. I don't know why it does that. It does its own thing. But you require that comma to create a tuple with one element. You should be able to create, if I remember correctly, an empty tuple. I don't know why you would ever do that, but these are the different ways of how you would instantiate a tuple, right? You just go ahead and declare your tuple. And the reason why when you create it, you already add the content in it is, well, for the sole fact that tuples are immutable, right? It's not like you can add things later onto it because you're recreating a tuple. So when you create a tuple, you just go ahead, open it up with parentheses, and you give it the value that you want to give it, right? So you can either add multiple items within the tuple or create a tuple with only one element. And you're going to require that comma here if you have one element. Let's go ahead and print this out. There is a hot mic. Please make sure you guys check your mics. But let's go ahead and run this again. All right, so we can. What are you doing? Okay. Notice here, right? When I took off that comma, it just shows a 4. Let's print out the type. And see how these change. Class tuple. Let's remove this comma. Class int. Right? Notice that when I remove that comma, it no longer classified it as a tuple. It is now classifying as an integer. By adding that comma in here, it's able to identify that it is supposed to be a tuple. So a little weird. I don't know why it's like this. Just be aware of that. If you try to create tuple with only one element within it, you require that comma, right? I love this method here, type. It's going to help you a lot to like debug and stuff and see where your data is. So just have that in the back of your pocket. Because we use parentheses in math equations. Is that what it is, Scott?
Yeah, I'm pretty sure because that's tripped me up before.
All right. Tuple operations. Since tuples are ordered connections like lists, some operations will work with tuples as they will with lists, right? Here we have coordinates, coordinate 3 and 4. We invoke the length method on the coordinates and save it into a variable called length. It's going to print out the length so we can see how that works. And then we also have membership checks, right? So this should be very familiar to lists. We can do 5 in coordinates. A membership check will return to you a Boolean, whether true or false. It's going to save that Boolean into this variable called is5 present. And we're going to print out is5 present. So we should see 2 different things print out here. One will be the length of coordinates, and one will be a Boolean telling us whether 5 was inside of coordinates. And we see here that length did work on the tuple. It gave me 2. And we're also able to do the membership checks just like we were able to do in lists. Some helpful methods which you can use on other stuff. I think you can even do it on lists, I'm pretty sure. Is stuff like min, max, and sum, which you should be able to do. Where is list methods? Why doesn't it have it here? I don't know why it wasn't on the list one. We'll talk about it in a little bit. But here's some very helpful methods. You'll probably use these a lot. I've used them multiple times throughout my time. Methods like min, max, and sum, right? It's another pre-built method that comes with Python that's going to simplify your life a lot, right? It's pretty common for us to add stuff, find the minimum of stuff, whatever. So, it's not surprising that there's some pre-built methods that already do this to save us the time of having to code this functions, right? Here we have a tuple of multiple different integers ranging from 1 to 100 in no specific order. Actually, not even 100. I think the highest number is 678 here. They're in no specific order. They share, no relationships. We're going to run the cell block. It's going to return to us the minimum, the maximum, and the sum of the tuples, right? So min was able to go through this tuple and find that the 1 was the minimum number in here. We were able to get the max, which should be 678. This is correct. And it was also smart enough to be able to add all the integers within our tuple and return to us 1597. As we progress through the tuple subject, I want to point out that tuples they're not commonly used, right? It's not a data type that you will use all the time. I maybe have to use it once or twice. It's very rare. So if you feel a little overwhelmed with all these different data structures and data types, just know that tuples is probably not something you're gonna use often. You probably won't even really need it in your interview. Honestly, a lot of things that you do in code can be just like variables, for loops, and lists and dictionaries, and how to use those. You can solve a lot of basic coding stuff just using those 4 subjects. If else checks, membership checks, those things would take you a long way with just basic stuff. Tuples, it's nice to know, it's important to know, right? To know the different data types that they're out there, data structures out there. But it's not a very common data structure to use. But because it is a data structure, we ensure that we teach it. Other methods that we find with lists that change the order of elements or alter the elements in a way will not work with tuples, right? And that's kind of self-explanatory. We know already that tuples are immutable. So it makes no sense that you can invoke the dot sort method on a tuple, right? They should return an error here. Tuple object has no attribute sort, right? Sort specifically is an attribute for lists and dictionaries. It won't work here. You're able to concatenate tuples together using the plus operator. Here we have tuple 1 and tuple 2, 1, 2, 3, and then 4, right? Because tuples are immutable, you can't, override one of these or change these, right? It makes sense to kind of recreate a different one. Here we have tuple 3 being created, and this is going to be the outcome of what tuple 1 and tuple 2 will be. We are also going to take tuple 1 and tuple 2 at index 0, and we're going to multiply them, and you'll get to see the output for both of these. We concatenate them very similar to how we did with like strings and stuff when we merge them together, the different tuples, right? And I believe the order does also matter. If we do tuple 2 plus tuple 1, right, it's going to change the order of this as well, right? So it joins them together. So you're able to concatenate tuples, and you're also able to do map. Now this one, actually, I believe this is going to give you some weird functionality. Yes, it did. And I'll explain that in a little bit. There we go. Tuple 1 and tuple 2, it gave us something weird here, right? Tuple 1, it took this entire tuple of 1, 2, 3, and it multiplied it by 4, right? But notice that it didn't do what you think it would do. You would think that it would multiply everything inside of it. 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. It did not do that, right? What it did was it duplicated the tuple by how many times you're multiplying it by, right? So it took tuple 1, which is the 1, 2, 3, and it multiplied it by index 0 of tuple 2. Well, what is index 0? That's 4. So it multiplied this tuple 4 times. So 1, 2, 3, and then 4, right? And it saved that outcome into tuple 4. So a little weird at first glance, but yeah, just know that it would do some weird stuff like this. Once again, tuples not something that you will see too often. Not a data structure that it's that common or needed. There's usually not a lot of data that you'd want to keep constant. Data is constantly fluctuating. You're adding, removing things, you're updating it. So there's not a lot of data out there that should stay constant. But it is a nice data structure to be aware of, and that to know that it's available for you guys, that it exists. So when you encounter this, it doesn't like throw you for a loop. Right? Do I have any questions about tuples? All right. I saw some head swivels left and rights. I'm assuming we're good here. Time is 7:53. We're gonna take our last 10-minute break of the night, and then we're gonna come back and we'll talk about what's left, and we'll call it a day. I'll see you guys at 8:03. We are actually done with today's official class lecture. We talked about lists and tuples. It's pretty nice to have some open room. We have assignments just like usual, like before. We can kind of go through them real quickly. You'll be given a list consisting of unique elements, except for one thing that appears twice. Your task is to output a list of everything in between both occurrences of this element in the list. Your task outputs everything in between. Okay, so what does that mean, right? So I know there's going to be 2 elements that are going to appear twice, and a brief example would be, let's see, let's look at the first example. We have 0, 1, 2, 3, 4, 5, 6, 1, 7, 8. So 1 appeared twice. Your task is to output a list of everything in between both occurrences of this element. So we have to output everything between both of these occurrences. So through the 2, 3, 4, 5, and 6 need to be outputted, right? And notice that it's checking whether the answer that returns back from doubles is equal to what is here, right? So here is the function called doubles, and you have to continue this function and complete it. So whenever you run this code and it runs these functions, it's comparing these two. If your code does what it should, then this should return true, right? Because it double successfully returns to you the numbers between both occurrences, which is 2, 3, 4, 5, and 6. It's gonna do a check here, right? Therefore return true, right? Does this make sense so far? So your job as a student is to complete the doubles function so that you're able to check and return the numbers between both occurrences of the elements that are not unique within this list. All right. Let's brainstorm. What's some couple ways we could do this? What do you guys know so far from everything we talked about? What methods could we use to figure out what values within my list are appearing more than once? A and D says a for loop. I do not want to use a for loop yet because we have not talked about for loops.
You
Do
can
you
sort
think
it first.
you said sort it? What happens if we sort it though? We have to. We want to output a list of everything in between both occurrences of the elements that appear twice, right? What if I have? What if these weren't sorted? What if these were random numbers? If I do sort it, what's gonna happen is it's gonna show me 0, 1, 1, and then 2, 3, so on and so forth, which is gonna change the order of the list. Therefore, I won't know what was originally between both of these ones, right? So sort maybe is not the best choice to go here because I'm gonna lose the current order and I won't know what numbers are between these two ones.
Would you do slicing?
We probably could use slicing. But I mean, we want to figure out. I'm trying to figure out a way that we can do this without for loops.
So if you ran sorted and not sort, that could put your duplicates right next to each other. Then you know what your duplicates are. Then you go back to your original list and you slice.
I can't think of any way to not do that, not use a for loop, if I'm being honest with you. Because we have, let's look at the methods that we have. We have list methods. We can use index, returns the index of the first element with the specified value, right? But that doesn't really help us. We're looking for duplicates. The only one I can think of that would probably be helpful would be the count method, right? The count method, I would be able to count how many times something appears in my list, but that would also require maybe a for loop, right? I would have to iterate through my list and count every single item in here, either manually or using the count method, which isn't practical because we haven't talked about for loops yet. So it'll be kind of getting ahead of it. Sorting, we could sort, right? If we sorted with the sorted method, like Scott mentioned, sure, it'll put it in order. But that still leaves it with the dilemma. How do we find which number within our list is appearing more than once? So I feel maybe this isn't the most appropriate assignment to do at this stage. I would put a bookmark on this, put a pin on this assignment because it looks like it requires a for loop to use until maybe after we're done with for loops, we can come back here and kind of tackle this as an additional for loop exercise. I keep getting the suggestion of creating another list to sort. Someone tell me what I'm not seeing here. why do we want to sort this list, and how would that help us figure out which numbers are duplicates, and how do we grab the numbers that appear between both duplicates? For those of you recommending the sorted list. Anybody? I see Chris is talking about, yeah, so I want to point out again, right? Let's read the question, right? Our task is to output a list of everything in between both occurrences of the element, right? We have a list consisting of unique elements except for one. There's one that's going to appear twice, right? In this first example, that number is the number 1, right? It appears at index 1 and whatever index this is. Our job is to print out the ones in between these occurrences, which is 2, 3, 4, 5, 6. Right? If we want to figure out what numbers are between 1 and this one, how is creating another list and sorting it going to reach that outcome? Because if we sort this, what this is going to look like is going to be something similar to this, where it's 0, 1, 1, 2, 3, and so on, et cetera, et cetera, et cetera, right? Once we get this sorted list, Chris, how do we know which ones are the duplicates?
I have a question.
Yes.
Is there a way to index both of the ones? So you could use the indexing to say, all right, the first one's at position 1, and then the second one's at position whatever, and then just do a start stop.
You could get the index. All right, how are you going to grab the index for the 1?
Well, you could do the index with just one. I know that technically index should just pull up, hey, the first number 1 is at position 1. It wouldn't tell you, I don't think it would tell you where the second number 1 is, but I'm wondering if there's a way to do that. That way, obviously this list is really short, so you could just do a start and stop by looking at it, but that doesn't answer the question of, how do I know to start and stop in between whatever number, number 1 or number 2 and the second number.
Right, so the index method is going to require us to hard code some kind of number in there so we can look at, where it's at, right? But this list can be 10 items. It could be 1,000,000, right? And we have to take that into consideration, right? So we need to go through every single one, and we have to find the index for these. How do you do that without a for loop? You can't, right? And that's what I'm trying to help you guys understand here, that as of right now, we don't have the skills to successfully accomplish this assignment without a for loop. So I want you guys to put a pin on this, and then we'll come back to this one with the for loop. And I think, to be honest, a lot of these are going to be very similar to these. I want you guys to hold off on these assignments that are in the curriculum. What I recommend for you guys to do is I want you to focus on the lesson 3 exercises, right? Lesson 3 exercises. I created these. The ones in the curriculum, I did not create those, specifically because we ran into a similar problem like this. So lesson 3 exercises is going to start you off pretty easy, right? Write a function that checks if a given list is empty and returns whether true or false. You can do these without having to utilize additional skills like for loops that we have not covered yet in the assignment, right? There's not as many exercises as there was for day 1 or 2, so don't feel too overwhelmed. I think in total there's like 5, 6, 7, like 9 exercises. Thomas Cromwell stays for in, right? yeah, we would require some kind of for loop, right? To go through these lists, right? Because we want to go through every single one and find out where the duplicates are. But we don't have these skills yet. So we'll put a pin on these, right? That way you guys don't break your heads trying to figure it out. I can't think of any other way to do this without using for loops, but we have not covered that yet. I thank you though for the feedback and the cooperation. Unfortunately, we don't know for loops yet, so I don't want you guys to do it. If you guys are comfortable using for loops, you've gone ahead, you have experience working with JavaScript or any other language, and you're familiar with for loops, then yes, I would challenge you. Go ahead and try it, and let me know once we get to for loops how that went. For those of you who have this is your first time doing it, don't worry too much about it. You'll get there. For loops is going to be next week on Wednesday, right? That's going to be lesson 5. Right, loops in data manipulation. Right. If you want to get ahead of the game, I encourage you as well. You can go ahead and look through it too. But as of right now, with what we have been teaching, I don't think you can handle this without a for loop. Sound good? All right. I'm glad we did cover it, so you guys weren't confused trying to handle this on your own, and wondering what was going wrong. But that's going to conclude today's official class. We're going to finish off pretty early today, which is pretty nice. Which hopefully we can open up the door for any questions if anyone has anything they want to talk about or stay here after class and discuss. But for the rest of you guys, I'm going to go ahead and stop the recording now.